Hello everyone. My name is Sudarshan Varma. I'm a postdoctoral researcher at the University of Arkansas. And my talk is about developing decision support tool for dairy and swine manure management system. Coming to our project overview, there's a huge demand and multiple pressures on the agriculture sectors due to continued global population growth, increased extreme weather change, and the resulting variability in reliable water resources. That requires water recycling to become an integrated part of agricultural water management. Simultaneously, the dairy and swine industry has grown steadily in the past decade and it is expected to increase. Hence, there is a need for and a drive towards innovative technologies that can better utilize and recycle water resources for food production. So the goal of this project is to develop a robust membrane-based electrochemical engineering technology to enable manure treatment and water nutrient recycling for food production. And also to develop a decision support tool that facilitates the selection of liquid manure treatment technology based upon local agriculture needs and nutrient balance requirements, with a focus on life cycle assessment model that projects the environmental and economic impacts for manure treatment technologies through multi-criteria decision making. There is a substantial heterogeneity in dairy and swine manure management practices across different farms, size, and geographic locations. These multiple individual practices include different collection methods, water usage for cleaning, bedding selection, handling, processing, and application, etc., which highly impacts the final effluent and solid nutrient characteristics. So in our decision support tool, we will recommend manure management alternative through the decisions made based on three primary criteria, that is economics, environmental impact, and the technology performance. Further, each of the criteria will have sub-criteria that are calculated or ranked with respect to many treatment alternatives that the user is allowed to select. For example, the different treatment technologies include lagoon-based systems, anaerobic digestion, solid liquid separation, membrane technologies, composting, etc. Further, the sub-criteria for economics will include capital cost, operating cost, cost savings, and revenue generation for each of the treatment methods selected. Similarly, environmental impact will include global warming potential, acidification, eutrophication, and ecotoxicity. Finally, the technology performance will be ranked based on the survey question or scoring methods, which will be discussed in later slides. The decision support tool has four major components. First is the user input sheet, where all the waste generation and treatment processes will be occurring. Next is the cost benefit analysis and life cycle assessment. Then the analytical hierarchy process for decision making, and the Python programming to read and perform calculations. The current prototype manure management tool is an Excel-based platform with empirical performance-based mass balances for several manure management alternatives representing current and emerging technologies and practices. The tool contains different subcomponents related to the collection and treatment methods, and also the user will be provided with placeholders with a reference guide to choose the recommended values, or they can input their own farm values. These components include different cleaning methods such as flushing or scrap systems and the amount of water used for cleaning, and different bedding methods, organic bedding including sawdust, compost, or inorganic bedding such as sand, and the amount of bedding used per animal. And the different technologies include storage pond, lagoons, anaerobic digestion, etc. And also we have IPCC greenhouse gas emissions, and finally the decision-making process. To give an example, we have the process flow diagrams, which include different collection and treatment methods. And we have performed the pre-calculated mass and energy balance for each of these scenarios based on the number of animals and the manure generated. This is one of the scenario where the user has flushing system with sand bedding followed by sand separation lane and treatment through anaerobic lagoon system. We also included recycled flush water to clean the freestyle barn and the recycled sand bedding to the cows, where all the components are included in our calculations. So these are a few more examples for a simple storage pond with flush system, and other is the anaerobic digestion scenario, which treats the scrap manure with organic bedding followed by solid liquid separator. Going forward, okay, this is the, the user input sheet in which the purple cells have the recommended optimum values of minimum to maximum range, while the first three options are used for animal type and the weight selection by the user, and the adjacent red colored column cells are used for the user input. Similarly, we have the same option for different variables like bedding, flushing volume, manure characteristics from milk barn center, etc. Once a user creates an input file like this, they can run the program and tell it to read their file. Then the program reads those inputs and checks validity and starts performing calculations based on the scenarios that we have defined. This would also include cost analysis and LCA. Then finally, the results are output to an Excel file. This tool also provides a reference guide with the recommended values for different components of the manure management system where the user can look up for values. And the treatment and mass balance calculations would include the following. For example, the total waste generated from the farm. We have the manure characteristics of all the manure generated like total solids, volatile solids, nitrogen, phosphorus, and potassium. And the treatment calculations are performed considering the loading rate, treatment volume, treatment or separation efficiency representing different treatment methods. And we have the final effluent and solid properties. Also, it includes IPCC Tier 2 greenhouse gas emission equations for all the treatment scenarios to understand the environmental impact. This is an example for a lagoon system calculated for 180 days, which include daily organic loading, sludge accumulation volume, storage volume for a 25-year, 24-hour storm event and freeboard, and the gas emissions. Similarly, below we can see the scenario for anaerobic digestion. We have all the engineering design factors. And once we have the output from the earlier slide, that is the treatment technology file, we use those values to calculate the environmental impact using the reference values from the LCA software CIMA Pro. And finally, we use all the values from the technology file, environmental impact and economic values to consider the decision making. Please listen to the presentation from one of our team member, Erin Scott, where we have the cost and benefit calculations linked with this decision tool. For scoring the treatment technology performance, we'll be following the scoring method offered by Nutrient or by some survey questions in future. And finally, once we have all the output values, we use analytical hierarchy process to assign priorities on each alternative by identifying the goals or the importance of attributes hierarchically. This hierarchy structure is composed from low to high levels on the basis of criteria and sub-criteria, and gradually leads to the decision of best manure management alternative. Coming to the conclusions, for now, we have developed 20 different dairy manure management scenarios with all the mass and energy balance. These mass and energy balance values are nicely linking with the economic evaluation and LCA. Also, we have prototyped the analytical hierarchy process for testing the decision algorithm to select and rank alternative solutions under local constraints. Also, Python programming is being developed and we are test running the code. Next, we are in the process of developing the model for swine manure management. Finally, I would like to thank the audience for listening and the conference organizers, our team members, and funding source USD and IFA. And here is my contact details. If you have any questions, I'll be happy to discuss. Thank you very much.